Hey guys, this is 9C. So the focus of 9C is differentiating when we've got negative powers. So if we look down at this question as an example, see how this one has negative powers? We're basically dealing with that. Now it's done in the exact same way as before, but before we have a go at these examples, I want to have a look at this first one here, which is differentiating by first principles, which we'd only ever do if we're specifically asked, and we are in this case. Now, it might not look like this has a negative power. I don't see any negative powers here, but it actually does, because if we move this x minus 2 up to the top, it's going to end up having that negative power. So its n value is going to be -1. Now there's a couple of questions in your book that are really similar to this. It asks you to do the same thing. A lot of people have a fair bit of trouble with it. So rather than me trying to do it in a small amount of space, I'm going to grab a book and do it there and show every single step, just so no one gets confused. Okay, so we've been asked to differentiate this by first principles. I'm not going to move the x minus 2 up to the top for now. I'm just going to substitute everything into our first principles rule here. So I need to make this x plus h instead of just x and put it in there and fill out the rest of the rule as well. As a reminder, make sure you don't forget to write this limit bit to save yourself any problems later on. Okay, so I've substituted everything into the rule. This looks pretty yucky, doesn't it? We've got fractions of fractions. What I'd like to do is just make it a bit easier to look at and understand. So I'm going to move this divided by h. Divided by h is the same as timesing by 1 on h. So that's what I'm going to show in this next section here. See how I've moved this divided by h over to here? So now we can kind of ignore it for the time being anyway, and just focus on what's happening here. Now these are two fractions with different denominators, aren't they? And they want us to take the second one away. In order to take that second one away, we need to make sure the denominators are the same. So we're going to have to do a little bit of cross multiplication here to make the denominators the same. So what I'm going to be doing is this. Just putting in extra room so I can show you what I'm doing. Alright, so we need to make the denominators the same. So I'm going to have to make sure I times this by both of these things. So x minus 2, x minus 2. That means you've pretty much just times it by 1, because that on that is 1. So you're allowed to do that. And on this side, I'm going to times it by that. So again, you've just times this side by 1. And now the denominators are going to be the same, so we're going to be able to combine those fractions. So I'll put that in the next line. As I said, I'm doing every single step here. You don't have to show all of this necessarily. I just don't want you to miss anything. Okay, so hopefully we can see that the denominators are now the same, so now we can combine those fractions. Another thing that's really important is you don't forget about this times 1 on h at the side, because you are going to need that in the end. Alright, so we've combined those fractions together, but now we're going to be able to combine all these like terms up the top. So in this next step, I'm going to expand out these brackets here. Okay, so I expanded them out. Now we're going to be able to collect some like terms here. So we can see that there's an x and a minus x, so they're going to disappear. You've got a minus 2 and a plus 2, so they're going to disappear. The only thing you're going to have left up the top is negative h. Alright, so now this is where our 1 on h comes in. So if we times this by 1 on h, that means 1 times negative h, and h times that. What's going to end up happening is the h's are going to cancel out. So that's what I'm going to show you in this next step. Okay, see how we have an h down the bottom and an h up the top? They're going to cancel, and that's just going to leave negative 1 at the top. Okay, now it looks like you could expand here, but I'm not going to bother doing that right now. I'm actually going to use this limit part. So I'm going to make h equals 0. If I make h equals 0, this is what we should get. Oops, I don't need to write that because that's what I'm doing. So x plus 0 minus 2, and then x minus 2. So what we end up having is negative 1 on x minus 2 squared. And that's your answer. You've just differentiated by first principles, and that's your derivative. So as you can see, there's a whole lot of steps in there. I took up more than half of a page, but I wrote down every single step. Some of those steps can be done really quickly. You don't have to write it down, but whatever works for you is fine. So we're going to do the rest of the questions now, but I might do it in my book instead, because I want to leave a little bit of extra room so it's nice and neat and easy for you guys to follow. So basically what we want to do for the next 4 questions is just differentiate using the power rule. So even though there's negative powers like there and there, it still works the exact same way. So you're going to take that power, multiply it by the coefficient, and then the power is going to go down 1. So let's do that. So with the first one, negative 3 times 5, which is negative 15. And then the power needs to go down 1. So it's going to go down to minus 4. A super common mistake is people make it negative 2, but that's actually going up 1. You want to go down 1 to negative 4. That's a little spot where people can make silly mistakes, so be careful there, because it will change your answer in the end. Now same with this one. So negative 2 times negative 4 is plus 8. Then your power of x is going to go down 1 to negative 3. This is just the same as what we saw before. That x can drop off, and that's a constant, so we can get rid of that one as well. Now here's our answer, sort of, but you can't have negative powers in your answer. So we want to change this so those powers are only positive. Now the only parts that we need to move down to the denominator are the parts that do have that negative power. So this doesn't have a negative power, so that can stay up the top. It's not the whole thing that has to go down the bottom, it's just the bit with the negative power. There we go. So that term is going to become negative 15 on x to the power of 4. With this next one, 8's got a positive power, 8 stays at the top, it's just the x that has to go down. So it's going to become x to the power of 3, and then we don't need to worry at all about this 3, that can just stay there. So that one's finished. Let's move over to B. Now, we can if you use another rule, but we can't really differentiate using the power rule right now because our x's are down the bottom. They're in the denominator. What we're going to have to do is move them up the top. Okay, so if we move them up the top, we should get something like this. Now remember, I'm just writing f of x here because I'm not differentiating yet. I'm just moving them all to the numerator. So this isn't a derivative. So that will become x to the power of minus 3. X to the power of minus 2 because we're moving them up. And this one, because it was negative and we're moving it up, it's just going to become x and then plus 2. Now what you might notice is this rule is the same as that rule. These are the same question. It's just that these were shown in a little bit of a different way because you've got everything in the numerator here, but this section, especially with those two, we made it so it had positive powers, but these two are the exact same thing. So I'm not going to keep going with that one because the answer is just here. Let's move on to C. Right, now this one here, you can use a rule called what is it again? Product rule. But we're not learning the product rule just yet. We can differentiate this using just the power rule though that we know so far. But what we have to do beforehand is expand it out. Now I should have written f of x equals. I might just fix that right now, just so it's easy to show what the original function is and what the derivative function is as well. So once we expand it out using index laws, so it's going to be x to the power of 2 times negative 3, so x to the power of negative 6, and we'll do that with each of them. We've expanded it out. Now this should be pretty easy for us to use the power rule to differentiate. Alright, so it's not focusing. Alright, so we've differentiated here, but again, we've got a little bit of a problem. We have a negative power here. We need to make sure we show our answers in only positive powers. So that negative 6 is going to stay up the top. It's just the x that moves down, so we get a positive 7 instead of negative. And the rest of it stays the same. Cool, so there's our derivative. Let's move over to D. Now again, we can see we've got something in the denominator here. Now you've got a function up the top, you've got another function down the bottom. There's a rule that we're going to learn called the quotient rule, which you can use to differentiate this. But right now we don't know that. We're just going to use the power rule. Now what I would like to do is I'm going to move this z up to the top and then expand it out. So we're doing something really similar to what we did over here. If we move this z up to the top though, it can't stay as z to the power of 3. It's going to change to z to the power of negative 3. Okay, so I'll move that up to the top, except I need to make that negative. So z to the power of negative 3. And now I'm expanding out, the same as I did over here. Okay, so I've expanded that one out. Now, this looks real similar to what we've done before, doesn't it? We can just use our power rule now to find the derivative. So, power times by coefficient, and then the power goes down one. Same with every single term. Plus 72. Yep, and then again, be really careful with those powers. Make sure you're going the right way. We're almost done. We just need to make sure we're showing our answers with positive powers. So let's move the sections that need to into the correct spots. So the Z goes down. This Z goes down as well. And the last one, the Z is also going to go down. And we are finished. Cool. So let's move on to our very last example. Alright, now this is one where we're solving for A and B. So it's a little bit different to what we have been doing because we were just differentiating there. This time we're actually applying it a little bit. So here's our rule, and this is the information that it's given us. So it says the gradient is -3 at the point 1 and 12. Now they've actually given us two pieces of information here. The line goes through 1 and 12, so that means that where x is 1, y is 12, so that's one piece of information that we have. But it's also said that the gradient's -3 at that point. Okay, so the gradient where x is 1 is -3. See how they've given us two pieces? Now they've given us two pieces of information and we want to find two different values. So that's going to work for us. Let's start with this one first because it's probably a little bit easier. Here's our rule where x is 1, y is 12. Let's substitute it in and see what we get. Okay, so 12 equals a plus b. Sweet. We can't really do anything extra with that. Let's look at this one now. So we've just been given your original function there, haven't we? But this is talking about a derivative function. It's saying that when x is 1, the gradient is -3. This rule doesn't tell us about the gradient, but we can use this rule to find the derivative, which has our gradient in it. So let's differentiate this. Now, in order for me to differentiate it, like I can just do it in my head with the x down the bottom, but it's probably easier if we move it to the top. So I'm going to start calling it f of x instead. There we go. So that's f of x once it's been changed. I want to find the derivative though. There we go. Let's make sure we have our positive power there instead. Alright, we have our derivative function now, so we can actually use this. So it tells us where x is 1, the gradient's -3. So where x is 1, the gradient is -3. Let's substitute those in. And that's going to give us that. So we have two different equations here. We have our first one, we'll call it 1, and the second one over here, we can call that 2. Alright, so this is just simultaneous linear equations. So I'm going to use elimination. If I do 1 plus 2, that's going to help me get rid of b. Okay, so I'm doing equation 1 plus equation 2 to eliminate b. Alright, so it's going to be 12 plus -3. So that's 9. A plus 2a is 3a. And then b plus -b is 0. So that means 9 equals 3a, so a equals 3. We've already solved for one of them. We just need to solve for b now. I'm going to substitute my a value into this rule here, and it should give me b. Okay, that's what I'm doing. 12 equals 3 plus b. So b equals 9. And there are our answers.